Recording has started.
So I labeled these equations A, B, and C so that we can refer to them quickly. And we see here that equation C is missing one of the variables. The Z variable is missing in that equation, which actually makes this way easier to solve using substitution. I'm going to solve equation C for x. So to do that, all I have to do is subtract 2y. So I get x equals 3 minus 2y. Remember, that's always our first step, is to pick an equation and solve it for one of the variables. Now that we've done that, that's still equation C, we have to put it back into the other two equations. So for equation A, x becomes 3 minus 2y plus 2y plus z equals 2. The parentheses here are serving no purpose because there's nothing that we can combine inside of them and there's nothing being done to them. So we're just going to take them out. And we will combine here now. Nothing to combine with the 3. Negative 2y and positive 2y cancel out, giving us z. 3 plus z equals 2. Now we subtract 3 from both sides. We get z equals negative 1. Now that's kind of an unusual circumstance there to get out here. Not only have one variable in the equation we substitute in, or only two variables in that one equation. That's a special circumstance in itself. But then when we substitute it in to have a second variable cancel out, that's a unique situation as well, a rare occasion. But it gives us the value of z. So we're already 1/3 of the way to solving this equation. Now we have not used equation B yet. So we're still using this equation C to substitute in. Let's put it into equation B. So 3x becomes 3 times 3 minus 2y. We put that in for x still. Plus 7y minus 5z equals 6. So now the parentheses here has nothing I can do inside of them, but this time I can multiply by the 3. So 3 times 3x, or 3 times 3 is 9. 3 times a negative 2y is a negative 6y. The 7y here is outside the parentheses, so it does not get multiplied, so that just stays 7y, and that stays minus 5z equals 6. So as I combine here, nothing to combine with the 9. Negative 6y and positive 7y is just a positive y, or positive 1y if you wish. And we have the negative 5z equals 6. And now I'm going to subtract 9 from each side to get this in our standard form. So the 9 goes away. Y minus 5z equals 6 minus 9 is a negative 3. So that is a two-variable equation. And technically, these two equations still make our two-variable system. But it's going to save us a lot of work because our equation A here is already solved for z, gives us the value of z. So we can come back to equation B over here and put negative 1 in for z, and now we'll have y. So 5 times negative 1 is a negative 5. Now I'm going to change this a little bit here. Y minus a negative 5 is the same as y plus positive 5. So to solve this, this is actually y plus 5, so I'm actually going to subtract 5. So y equals negative 8, correct for that? Apparently. So we get y equals negative 8 there. Then going back to solve for x, I put y in here. X equals 3 minus 2 times negative 8. Giving us x equals 3. 2 times negative 8 is a negative 16. So 3 minus a negative 16 is 3 plus 16. X equals 19. So we get x is 19 when y is negative 8 and z is negative 1. That actually is correct. That does work out. Okay, so we can see this system here, because of the missing variable in it, was fairly easy to solve. I mean, there were other special circumstances as well, but was fairly easy to solve using that substitution method. Well, today we're going to keep practicing substitution. Oops, go ahead.
So when you were doing B, when you put that 3 minus 2y into B,
Yep.
couldn't you also put that negative 1 in for Z?
We could have done that at the same time. You are correct. But I'm trying to go through just a consistent set of steps. And remember, our first step that we want to try to do is to reduce the 3-variable system to a 2-variable system. So I was just trying to stay consistent with that. But you are absolutely correct. You could take a shortcut and you could have put in negative 1 for Z right there, and then the only variable we would have had would have been Y. Yep. That would save you a little bit of work. Okay, so let's take a peek at another one here. So in this system, once again, I'll label them A, B, and C just so I can reference them easily. There are several possibilities of variables that would be easy to solve for. Solving for y in this top equation would be easy. Actually, solving for z wouldn't even be too bad there. Solving for x in the second equation would be easy. Solving for y in the third equation would be pretty easy. I am going to go ahead and solve for x in equation B. So let's do that. I'll write it over here. Here's equation B. So we currently have x minus 2y minus 2z equals 6. To solve that for x, I'm going to add 2y. That gets rid of the minus 2y. And I'm also going to add 2z to get rid of the minus 2z. So the negative 2y and the negative 2z are gone. I have x equals, on the right side, that's 6 plus 2y plus 2z. So there's my equation B that's been solved for x. Again, I could have solved equation A for y or equation C for y. Would have been just as easy. I just chose that one because that's the one I felt like using right now. So that was equation B. We do have to go back to the other two equations. So let's do equation A here. 3x is going to become 3 times 6 plus 2y plus 2z plus y minus z equals 2. We're going to go ahead and multiply the parentheses there by 3. 3 times 6 is 18. 3 times 2y is 6y. 3 times 2z is 6z. The y here is outside the parentheses, so it does not get multiplied, neither does the negative z. And now we'll do some combining. Nothing to combine with the 18. 6y and y is 7y. 6z and negative z, 6 and minus 1 is 5, so that's 5z equals 2. And now to get this into standard form, I'll subtract the 18 from both sides. So 7y plus 5z equals 2 minus 18 is a negative 16. That's equation A after we've substituted into it. I have still not used equation C. We're going to come back there, 4x. Again, we're going to put in the 6 plus 2y plus 2z in place of x. Plus y plus 2z equals 7. So again, nothing to do inside the parentheses, so we're going to multiply by the 4. 4 times 6 is 24. 4 times 2y is 8y. 4 times 2z is 8z. Once again, the y is not in the parentheses. It does not get multiplied. Neither does the 2z. We'll combine here. Nothing to combine with the 24. 8y and y makes 9y. 8z and 2z makes 10z. That still equals 7. We'll subtract 24 from both sides. Put it in our standard form. We've got 9y plus 10z equals 7. That's equation C. That is the second equation in our two-variable system. I'm going to rewrite it up here so these two are together. Now, looking at these two equations, there is no easy route to solving this two-variable system. We did use substitution to reduce our original system here down to that two-variable system with two equations, but we don't have to continue to use substitution. To solve the two-variable system, we can switch over to a different method if we want to. Now, obviously, I'm not suggesting graphing. I am suggesting switching over to elimination or the addition method. And the reason is I see that if I multiply this top equation here, equation A, by a -2, the z is going to cancel out then. So let's do that. -2 times 7y is a -14y. -2 times 5z is a -10z. Equals -2 times -16 is a +32. That's still equation A, we just modified it. We're going to leave equation C as 9y plus 10z equals 7. Oops, I did something wrong there, just a second here. 7 minus 24 should be a -17, not a 7. So this should have been a -17. So this would be -17. That makes a lot more sense. Sorry about that. So what we change there? Right there. Okay, so now we've got that fixed. We have this system here where we're ready to add the equations. -14y and +9y is a -5y. -10z and a +10z is 0z, so that just cancels out. Equals 32 plus -17 is a 15. So to solve for y, we divide by -5. Now we get y equals -3. Now, next, remember, once we get that first solution, we take it back to our two-variable system, and we solve for the other variable that was in that system. So I'm going to put it in here for y. 9 times, instead of y, I'll put in -3. Plus 10z equals -17. 9 times -3 is a -27. Plus 10z equals -17. We will add 27 to get rid of the -27. So we have 10z equals 10. And now we just divide by 10. Z equals 1. Now that we have two of the variables, we have the y and we have the z, we go back to one of the original equations to find x. The one I'm going to use, since we did substitution, the big advantage is we should have one equation already solved for that variable we're looking for. And we do equation B, we solved it for x. So I have x equals 6 minus 2 or plus 2y plus 2z. I will put in negative 3 for y and 1 for z. So 2 times negative 3 is a negative 6. 2 times 1 is just 2. Well, negative 6 plus 6 is just 0. 0 plus 2 is 2. So x equals 2. So our solution to this system here, x is 2, when y is negative 3, and z is 1. Now, has anybody had any major difficulties solving any of these systems? Okay. I mean, it is definitely a lot of steps. The biggest advice I can give you is go slow, take your time. You can see me trying to push through these and rushing through. I've made a couple stupid mistakes, like 17 minus 24, not doing that correctly. And also, stay organized. I probably have not done the best example of modeling this for you here, because I'm trying to keep everything as close to one screen as I can so that you can see everything at once, or as much of everything at once. But if I were doing this on paper, I would be trying to do it, here's my system, and I'd just be here step 1, step 2, going right down the sheet so that if things didn't come out nicely, didn't work out well, I could go back up and follow my steps down in the same order I did them and see if I can find a mistake. The way I did them up here, it would be tough to follow my steps because I didn't go in a straight linear fashion down the page there. So staying organized helps you, if it doesn't work out, to go back and go through your work. So now, that is it. That's all I wanted to do for the substitution method. I plan to give you about 20 minutes of work time to work on those. But because we have the 2-hour class today, rather than giving you your 20 minutes of work time right now, the homework for the first hour is that worksheet from yesterday to go back and do the odd numbered problems. Because yesterday we did the even numbered problems. But again, rather than giving you work time to do that here in class, I'm going to continue on to the next step. So our next